going to talk a little bit about how you can build products on top of GenAI, but ensuring that they are working as you would intend. Like you're building a product feature, a product, and you don't want it to be abused or used in a way that you didn't intend initially. As Daniel said, I've been at LinkedIn now for 1.5 years as a Senior Director of Engineering, and I support 3 pillars, which is trust, privacy, and responsible AI. Before that, I was 8 years at Meta, even though I didn't meet Joe or Daniel there. And this is how I'm structuring the talk today. I will spend around 10 minutes just introducing what I mean by trust and responsible AI so that everyone is on the same page. And I will spend most of the time talking about, hey, what are the different phases and defenses we have to build so that you can build product features with trust and with responsible AI by design in your mindset. And if I have time, I will try to spend a little bit of time also talking about how we use GenAI in trust to make more efficient our tasks. So LinkedIn, probably all of you know, our mission is to create economic opportunity for every member of the global workforce. We have 3 major areas of our products. We have knowledge sharing, where you can connect with people, you can send messages, you can post, and there are people that are consuming on the feed the content that is being created. We have a suite of products that are supposed to help you with your professional career. That basically means finding your next job or helping recruiters to find the right candidates, as well as learning new skills in your job or for your next job. There is a third one, which is about helping marketeers and sales professionals to find the right prospects on our network. All these products, like in many other products, we have AI services that are making these more personalized, more advanced, whether it is search, recommender systems, or we are optimizing, for instance, pacing and bid optimization for ad networks. We recently started also launching GenAI products or GenAI-powered products, like, for instance, collaborative articles and coach, or how to improve your profile with GenAI, basically the text or summarizing some of the context in your profile. For all these products, and my team is basically an horizontal team that is ensuring that we build these products with trust and responsible AI by design, and we are ensuring that it is used in the right way, the way it was intended, and not misused by any bad actors. So what do we mean? Trust, I think everyone, trust, integrity, probably everyone understands. You have seen things in social networks or in platforms that might be illegal, might be inappropriate. So these are some of the examples that you could find online. There is also unoriginal or lower quality or borderline content. Unoriginal could be you basically copy a post from someone else and make it pass like if it is yours. You have misinformation, like that example there is from news about the prime minister in Japan, which was basically non-factual. And then you have also the problem of knowing whether the person you are interacting is authentic or not. Like that example is from an account with more than 500 connections, which was actually a fake account. The person behind was not the person that was portrayed. These are all trust problems that we have to address if you want to build a product that is working as you intend and that you are trusting. Responsible AI, this is still, there is a lot of research in this space. And it contains multiple dimensions. I'm simplifying it into 3 dimensions mostly, and I will have one slide for each one of them. One is fairness, and fairness is ensuring that the AI models that we are building is treating everyone equally. It's not discriminating based on demographic group, it's not creating stereotypes, etc. We focus on measuring whether AI models at the training time, they are biased or not. And if we find that those models have any bias, then we mitigate it. We basically do either better sampling or post-processing, etc., so that we can avoid that those models are biased. Transparency is about understanding what your models are doing. And whenever you're in a large company, it's very easy to basically not track all what your models are doing. Like LinkedIn has hundreds of models, and what we have is a governance model where we have model cards for each one of the models, saying who is accountable for that model, what the model is doing, what it's used for, is it using private information, etc. It's also about explaining to your users when you are applying AI and how it is being applied, why they are being recommended, for instance, a specific item. The third one is privacy. This is extremely important. There is a lot of regulation. We have to build any product with privacy by design. And on top of that, we are developing privacy-enhanced technologies so that we go beyond regulation in order to protect the data, even in those situations where we have to use sensitive data. So going into more details, fairness is a very important topic. It's also a topic where, if I was to ask in this group what your understanding of fairness is, probably we are going to have also different definitions, different perceptions. There is a tutorial some years ago from a computer scientist at Princeton that is talking about the 21 definitions of fairness. The problem is that some of those definitions actually conflict with each other. So let me put you an example. There is the definition of equal treatment. Basically means you are going to treat everyone equal no matter what. You also have the definition of equitable outcomes, which basically means you are going to provide the outcomes in an equitable manner. You can see in this picture how in order to achieve equitable outcomes, sometimes you are going to have a non-equal treatment. So you can see how these two things might be in conflict, and that makes this area very, very challenging. The way we are trying to address this is disentangling both concepts. In my team, we are very strongly focusing on equal AI treatment. That basically means we want our models to not increase bias or differences across demographic groups. And then on top of that, you can have product equity, which is going to address the equitable outcomes very often with non-AI initiatives. Sometimes it's about bringing more diversity into your network. Sometimes it might be changing UI so that some demographic groups that are interacting differently with your product are also going to get some they're going to get more targeted flows. Some examples of how you could see fairness being or non-fairness in a product. One of it is called allocation harm. There are some areas in a product where you have real estate. That basically means you have to choose what you are showing at a given time. In this case, imagine recruiter. A recruiter is looking for a job. Whether a given member is shown in the search list or not, that might be what actually determines if that person is finding a job or not. It's extremely important that you are showing that list based on qualifications and that the demographic group that you belong to is not playing any role. So that's one example of how important it is to be fair whenever you are generating those recommendations. The second one is viewer side. If I go into the platform, I want to have the same quality of experience that any other person from a different demographic group. If I'm from one gender and I'm being shown recommendations for jobs that are a higher level than another member, even though my qualifications are the same, then that wouldn't be a fair situation. The third one is about stereotyping. Basically, you look into the content and then you're looking, are we creating unfairness in the content that we are generating or that we are showing to the members? For all of this, as I mentioned, we focus on measuring whether that happens with any of our models, and then we mitigate in case that measurement shows that there is any bias. Responsible AI, and again, going towards what I said, there is an internal aspect, which is we build model cards, and we have, for each of the models, we have information about who is the POC, how is this being used, is it being shown to a user, or is it being used by a human in order to make a decision. We include all the measurements about fairness and inclusiveness that I was mentioning about. We also talk about what are the methods that we are ensuring or that we are putting together to ensure the quality of that model over time. And we have privacy information, whether there is any any sensitive information, like personable, identifiable information in that particular model that is being used, etc. There is also the public aspect of it. This is, again, candidate search for a recruiter. And what you can see, this would be an example of one candidate that is being shown. And within that, there is a section that explains why that candidate is being recommended. And we are doing that by using integrated gradients so that we can identify what are the features in the model that were critical in order to make that particular candidate show up with a higher rank. In this particular example, it shows that it has a high likelihood of interest, and it explains that it's because it changed the status to open to work. It is a company follower of the job that you are, or the recruiter is currently looking for. It's closer in your network because it has one connection in common, etc. So this is also very important. It's not only about what you do internally, it's also about your users understanding when and why you are using AI, because what you want is to build trust on your users so that they trust that you are having their best interest in mind. And then to finalize, privacy. Again, a lot of privacy is about regulation. We follow all regulations and we are compliant. We are also following all the changes that are happening on specific platforms like Apple, AT&T. But we try to go even beyond that. There are situations where we are using sensitive data because it's part of the product. And in those situations, what we do is we develop privacy-enhanced technologies so that we can try to we can actually manage that data in a more anonymized manner or in a more sensitive management manner. I will pass this one. So generative AI, it's a revolution. Like I think everyone knows that ChatGPT is the fastest adopted at-scale technology ever in history. It presents so many opportunities, but at the same time, it also presents many risks. And there are different risks. Just to put some examples, one is it actually makes cheaper and easier for people to do things that are abusive, that can create harm, etc. It also allows many companies to be more efficient, more productive. In our case, also to do trust and protecting our platform in a better way. The third one is it allows you to, which is what most of the people are thinking, it allows you to create better features. It allows you to prepare better products. And this is the part where I'm going to focus most of this talk. Whenever we are using generative AI to build products, how do we do it with trust and with responsible AI by design? Let me first start saying, what are the different patterns, the different use cases that are not the standard ones, that basically come as unique because of generative AI? The biggest change is that in the past, you would have user-generated content, and then the platform has to ensure, with the best capabilities possible, that that content is appropriate for the platform. Now, the platform that you are using is actually generating the content. That basically increases the expectations because you have to ensure, this is seen as coming from LinkedIn, so you have to, or we have to ensure that all the users perceive that as a very high quality content. So there are three main scenarios. There is one where we generate the content. One example is collaborative articles. We have multiple number of questions or topics that are relevant for professionals. And then we precede a draft of an answer or an article to basically address that particular topic. And then we feed it to experts that can modify it collaboratively and they can work on it. The goal of this is that they don't have to start from scratch. It's a lot more efficient. But at the same time, you have to ensure that that first draft is appropriate. And again, if we go towards the examples I was providing before, there is nothing harmful, it's not biased, etc. The second one is a user can provide a prompt or a piece of text that already exists on their profile, for instance, and we are going to provide a tool that might make it better, like make your summary on your profile more professional. Again, this is a situation where now the user can provide different inputs, can actually try to do something that is unintended as well. So this is new. We didn't have that in the past. The third one is the whole aspect of conversational agents, where you are having a full conversation over a period of time. Within these three use cases, this is what is new. From a product experience, now it's interactive. That basically means that latency matters. In the past, if we were taking seconds to detect if content was not appropriate, that was fine. But now you are interacting, you are generating a response. We have to do this in milliseconds. Second one is now members or users can input data, whether it is directly in a prompt or whether they fill it into their profile and then it's being used. So there is a lot of unexpected potential consequences of doing that. The third one is, in the past, if we had a blind spot, we can also rely on other users to report whenever our systems are not working properly. In this particular case, if you have a private conversation, we may not have that capability. From a development process perspective, the speed of iteration. Now you can modify prompts from one day to another, and it's changing how the product is working. We can do, and I will talk later about red testing, but the way that it was done in the past with manual red testing that takes a week, et cetera, it doesn't scale anymore. So this is also a new change. And the final one, which is the one that I mentioned before, the perception changes. Now we see this content as being generated by the platform, by LinkedIn, and therefore the expectations of doing a great job is a lot higher. So let me tell you how we are approaching this. I wrote, we do this at LinkedIn. It's probably very generic, but since all the companies are trying to figure out how this is working, I figured I wouldn't generalize it as everyone has to follow this. The key aspect here is going to be this graph that I have on the left, but I will go with one slide in each one of them. There are two particular defenses that apply to the whole product development cycle, which is requirements for every maturity or for every phase in your project. You're going to have different requirements that you have to fulfill. If it is a beta, alpha, or a general availability product, then you might be increasing the requirements in order to ensure that your feature, your product is working as intended. Second one is red teaming. That also has to happen along the whole process of development of your product. And then the way the product works is going to have multiple defenses. One is access control. Do you want all your users to use it? Or do you want to only have those users that you believe are going to use it properly to start using it? Second one is how do you control the prompt? There are new attacks like jailbreaking. And also there might be users that go doing something that your product was not intended for. So basically intent detection is also important. Your LLM, you have been hearing today from the keynote and from Joe before about alignment. That's very important. If you are using a model that is aligned, that makes your life a lot easier. If you are using a model that is not aligned, then you probably have to do that work because it will make the rest of your defenses a lot easier. Final one is you have to review whatever is the output of your system because that's what your users are going to see, and that applies to a lot of the standard techniques and classification techniques that are used in trust in general in the past. Now, all this is never a perfect system. So we are going to make mistakes, and you have to account for whenever those mistakes happen. Whenever we build a feature, we are always thinking in the best way how this is going to help everyone, and it's very difficult for any one of us to think about how it can not work the way we intended. But you need to have some of these fail-safes. So one is feedback. Your users can give you feedback on whether something is meeting their expectations or not. And the second one is you need also your independent measurement so that you can evaluate this by yourself. So going one by one, this is an example of requirements that we are setting for the development process at LinkedIn. And it varies depending on the maturity of the product, from a private preview, which is basically a beta with a very small number of users, to whenever we are making this publicly available. There's a lot of detail here, so we don't need to go into all the details. But for instance, if we think about testing, if you are going to show this to a very small group of people, and what you want is very fast iteration so that you can gather feedback about product market fit or about the basic functionality, you probably don't need to have like a full automated red teams testing available. You can do some quality testing. But as soon as you are expanding the number of users that you are going to have, then it becomes critical to start having red testing, to a point that we actually do red testing, manual red testing for any major release that we are creating. The same happens for UX. You can start with basic user feedback, but then eventually you may, if you are making this available to everyone, then you also have to account for potential misuse. And then, for instance, you may set up some thresholds of how often that can be used. If you have a user that is making more than 500 queries in 10 minutes, that's probably not the way that you are expecting any human to use it. That is probably an automated bot. The other one that I was mentioning that applies to the whole development cycle is red testing, manual or automated red testing. The way we are using it is for any major release, we use vendors or our internal experts to do manual red testing. Red testing basically means you have a group of experts that are going to try everything that can go wrong. The goal there is to find vulnerabilities, is to find gaps, is to find situations where your product is not working the way that you were intending. So we do it manually. The benefit of that is that you have a human in the loop, so there is a lot of judgment. But it's very expensive, and it doesn't scale. It takes a week, so you cannot do this all the time. So what we do is all the output from those exercises, we bring them together, we build a benchmark, we augment that benchmark with some additional generative AI generated red content, and then we create that benchmark that can be run automatically in a more regular basis. So the benefit of that is whenever you have major updates, you can do manual. It's very expensive, but it makes sense. But then every time that you are having iterations, and I was talking about the fast-paced development in this space, then you can also look for regression testing. So you're getting the best of both worlds. When we are talking about automated red testing, it's also very important to understand what you are exactly testing. I didn't explicitly talk about it, but there are different layers of defense and different aspects that we are actually testing. If you have someone, for instance, that is trying to jailbreak, and that's the test, the adversarial test, then you want your input moderation layer to detect that. You don't want it to go through. If you are trying to test someone going off topic or trying to, if our chatbot is about professional growth and someone is talking about something entirely different, you want to detect it into the intent detect layer. And then obviously, if the input and the intent is correct, then you will want to detect it at the output moderation layer. Now, those were the two things that apply across the whole lifecycle. Now, let's see whenever a user or whenever you have a product at the different layers of how the product is being used. The first one I mentioned was access control. Every platform is going to have a percentage of people that are probably not even real people. It's bad actors that are trying to misuse the whichever feature, whatever product that you are offering. So how to try to identify, because what you are giving them with some of these products is superpowers. They're going to be able to do so much more that it has the risk of creating a lot more harmful that they could do otherwise. So one way to solve this is to create tiers where you can classify your users and give different access to the features that you are generating. You could have, for instance, the two tiers where you have very high confidence these are good users, and they have full access to your capabilities. And then you may have some users where you may not know or you may have high confidence that they are probably not good, but not enough so that you can restrict them from your platform. And in those cases, again, you don't want to give them the superpowers to access those features. The very critical aspect here is you have to provide anyone that is in a lower tier the way to get into a higher tier if they are good. And it has to be done in an equitable manner, so everyone in your user base has to be able to do that. One example, for instance, would be if you verify. LinkedIn now offers the opportunity to verify through your employer or to use Clear in the US. We use other vendors in other countries so that you can prove that you are who you say you are, and that immediately will give enough confidence that you are going to use the product in the right way. Because one of the assumptions for bad actors is that eventually they get caught and then they have to come back with a different identity. The other one is content understanding. And in the past, it has been mostly about understanding the output. Now it's also about understanding the input. But the input and output look very, very differently. So you may need to have different defenses for each one of those. Like if you think about a new risk, input now is, as I was mentioning before, is talking about jailbreaking. Someone is going to try to understand and get exposed the meta prompts that you are having. Or it could be that the intent is different with what you were planning. And it's not necessarily adversarial, it's not necessarily bad, but it's not the way that you intended your product to work. So you have to detect that at the input level. Another one is the content of input is more a question, while the output is going to be sometimes more of an answer. So again, you have to potentially train them differently because you are looking for different patterns. The final one is you have to consider the UI into account. If you are in a conversational chat, and the user is putting a prompt, then the answer, you're not going to wait for the full answer because it takes multiple seconds to basically show it to the user. You will start generating a stream of characters based on how the answer is being generated. If at any time, and you have to evaluate per chunks, if at any time you discover that there is something that might be harmful or abusive or inappropriate, then you actually would have to remove that whole piece of text that you have shown to the user and probably restart again the query with different parameters. Some examples of things and how they apply to input and outputs. Jailbreak applies to input. Protection for prompt leakage is something that applies only to the output. Self-harm, for instance, would apply to both of them. Hate or harassment typically depends for the input, because in some cases you may want to allow some expressions to be used by users, but it's definitely not okay as an output. So this is a non-exhaustive example of some of the problems that we are constantly looking for whenever we are evaluating these models, and we have defenses and protections for each one of them. We use in-house classifiers. We rely heavily also with and collaborate with the Azure AI safety team. And we also evaluate and use open source models, including Llama and LlamaGuard, which was mentioned in the previous talk, whenever we see in some of the scenarios that they perform very well. Now, we talked about what happens before and after you are making the call to the model. It's very, very important what the model itself does. And once again, if you have a model or you try to use a model that is not aligned, then you're going to have a pretty hard time trying to filter all the outputs. So either rely on a model that is already aligned, like for instance, Llama or GPT models, or if not, then you will have to do the alignment yourself. And Joe was talking about how to align a model. You have here some examples as well. I'm happy to discuss more about it. But it's very important that you are already training or fine-tuning your model in a way that is giving you reasonable answers, and you only have to fill the gaps. The final one is feedback and measurement. Feedback, how do you get your users to tell you if something is not according to the expectations? And there are two categories. One is quality-based. Is the quality of what you are getting according to what you expected? And it might be low quality, and then you have to improve and optimize, but it may not be inappropriate. The second type of feedback is whether something was really inappropriate. It should not have even been generated in the first place. It can be harmful. And then we have metrics for these two separate so that we can track it differently. We have guardrails whenever we are launching models, and if at any time during training, evaluation, testing, etc., any of those guardrails are not met, basically the release of that particular feature or product is blocked till whenever it is fixed. The other one is bias and stereotypes. There are two types. One is incidental. Basically, it means you look at it, it's a single piece of content, and you realize or you can assess whether there is bias in it. There is very obvious ones, like that example, every junior engineer should discuss his career goals with his manager, which obviously is pre-assuming one gender. There is less obvious ones that requires a lot more domain knowledge, like new mothers ought to pause their career and stay home with their babies for 2 years. Those are more complex because it requires a lot more context and domain knowledge. Then there is also the representational bias, which is not something that you can see in one single piece of content. You need to look at multiple of them. And again, examples there would be if you're asking for articles of science careers, and it only gives examples of male scientists, or if you're asking doctors, and the response is basically always white men, for instance. So this is still an open research topic. There is a lot of work in literature being done, and there are multiple challenges. One of these is bias and stereotypes can be subjective, and they might be also context dependent. Some of it is that it's very difficult to collect enough training data or examples so that we can evaluate properly many of these aspects. We are using multiple solutions to address this. Some of it is even leveraging LLMs, but as it was mentioned in the keynote today, you're basically using AI to evaluate AI, so there are also some risks on that. We have different levels where we are combining human and AI in order to assess some of these situations. And the solutions at the end, if you detect that this is happening, you can retrain your models with more or fine-tune with more balanced data. The other one is you can actually change your prompt in order to ensure that there are some of these instructions that are going to generate the content in the base in the way that you want, in a more balanced manner. I will spend 3 minutes more just talking about other uses of Gen AI within trust tasks. Everything that I've been talking about is how to protect some of the generative AI products that we are building. Now, within the standard responsibilities of a trust team, how can we use generative AI to simplify our work or to improve our performance? One example is ML-assisted sampling. One of the problems with trust is the violations, the abusive content, the things that you don't know. So we are very good at detecting things where our models are trained to detect them, or our users are telling us, hey, this is something that you missed. There is a huge portion of things that might be happening in our platform that we don't know about because neither of those are flagging it for. The only way to get access to that is through sampling. You basically sample from live content, which you show it to humans, and then the humans are going to tell you, yeah, this is good or it's not. The problem is that if your platform is minimally good, the amount of bad things whenever you do random sampling is really tiny. This is a very big class imbalance problem. So most of the cost that you are having on human labeling is actually wasted. You can actually solve that by using ML-assisted sampling, where you create a model that will tell you the probability of something being bad, and then you are stratifying your sampling based on that probability distribution, and then you can unbias the estimator based on that. You can reach 70% cost reduction with respect to random sampling and a lot tighter bars whenever you are doing these measurements. So again, it's a much more cost-effective manner. Another one is probably not a surprise to many of you, but now it's extremely easy to generate content, and that implies also generating pictures or profile pictures so that you can create easily more and more fake profiles on LinkedIn. We have models that are detecting AI-generated profile pictures. It works actually pretty well, so precision and recall are very high in the 99 and 85% respectively. And it detects profile pictures being generated with StyleGAN, Stable Diffusion, DALL-E kind of models. The challenge with this is that there is an increasing number of models, and then keeping up to date with all the new developments requires a lot of development effort, of course. The last one that I will be talking about is, I was talking about human labeling. It's very expensive. Any trust team typically is going to have a combination of automation and some human labeling. And the reason is, unlike other scenarios like ranking, for instance, which might be very focused on precision, in trust we need to have very high precision, because if you make a mistake, something bad goes through, or you are stopping good content from a good actor. But you also need to have very high recall, because you want to ensure, again, that you are not missing anything. Because of that, almost any trust system is going to have a first layer of AI that automates. It's too expensive to review everything by humans. So you will have a first layer that is going to probably automatically making decisions for most of the content that is created. And that's for the content where your models have a high confidence that they are making the right choice. Now, there is a portion, if you want to go and you know how the precision recall curves look like, where if you want high recall, the precision goes lower. And in that case, you need to have an extra review. That extra review typically has been done by human labelers. But the problem is now with generative AI, the capacity to create content, the amount of volume of content that is going to be created is increasing significantly, and it's not going to scale to keep growing human labeling at the same pace. So we need to automate some of that as well. So we are exploring and utilizing different ways where human and generative AI models that are more expensive, they cannot be run at the very front line because it would be too expensive, but we can put them side to side with humans in order to get the best of both worlds. Some content will go only to generative AI. For instance, something that is very obvious, very bad, that's also good for the well-being of the human labelers. And sometimes they can work in combination, and you look for both of them, and then you get decision quality increase. And sometimes it will continue being only human. But there is going to be a way where we can scale to the amount of content that we expect is going to be created. And that is the end of the talk. Thank you very much.